Hello there, my name is Patrick Barrett. I am the author of the SAT Prep Black Book 3rd edition, and last week I posted a video asking you guys to help me pick which question to make a detailed walkthrough video about. And the top comment was here for this question, 4661E2A9. So I went ahead and found that question in the College Board's free SAT practice question bank. And here it is. Like any real SAT practice question, there's a lot that we can learn from this question because the whole point of a standardized test like the SAT is that it is standardized. Every question has to follow the same set of standards as all of the other questions, and that's why we can compare scores from one test date to the next. So we can learn a lot about this question by talking through how to solve it, and then we can also kind of step back and learn some bigger lessons that will help us as we continue with our preparation if we take some time to think through the concepts that appear in this question and how those concepts are presented. So first we will focus on just doing this solution, and then we will go ahead and discuss some of the bigger lessons that we can learn here. Let me mention one more time before we jump in here that this question is taken directly from the College Board's real SAT practice question bank. As always, I don't ever recommend working with anything other than real SAT practice questions from the College Board, and this is one of those. You can find those questions in that question bank, and then you can export them as a PDF, which is how I ended up with this question in this format here. I only mention that because sometimes people find fake SAT practice questions online and the format looks a little wonky. I kind of think that when you export these as a PDF, the format ends up looking wonky too. But this is not one of those fake questions. This is a real question right from the College Board's website, and you can verify that for yourself by looking up this question using that ID number you see right here on the page. Anyway, this question provides the equations x minus y equals 1 and x plus y equals x squared minus 3, then asks which ordered pair is a solution to the system of equations above. This is a great example of the College Board presenting a math question that at first glance is pretty similar to things we would see in a normal math classroom, but then when we look a little closer we notice this x squared here. In most high school math classes, when we're dealing with solutions to systems of equations, we do that in the context of linear equations, right? Not equations with exponents like this one. It's not a big deal. We're still going to be able to solve it just fine, but this is going to be, for most students, a little bit of a difference from what they're used to seeing in a classroom. Now, the way that a lot of students would instinctively start to solve this question, and the way that a lot of math teachers would want you to solve it, would be to take one of these two equations, solve it for one of the variables, plug that value that you find for the variable into the other equation, solve for the other variable, and then finally plug that value back into either equation. That can work here, and in fact, this is the solution that the College Board provides for this question, which, as we often see from the College Board when it comes to explanations for their own math questions, is very algebra heavy, very formal, very much the kind of thing that a math teacher would like you to do. As we discuss repeatedly in the SAT Prep Black Book 3rd edition and in these walkthrough videos, in pretty much every case, the quickest, easiest, and most reliable way to answer an SAT math question, a real SAT math question from the College Board, is going to come when we avoid these sorts of formal algebraic classroom solutions. We're not going to use the DESMOS calculator on every single question, but we are going to tend to use it pretty heavily and to look for ways to use it because it is incredibly powerful and can save us a ton of time. So if you're interested in an algebra solution to this question, here it is, straight from the College Board. This is the way the College Board tells you to answer this question. I'm not even going to bother going through that solution. I'm going to show you several solutions to this question. None of the solutions I show you will be that algebra solution. And the reason isn't because I don't think algebra matters, or I think algebra is stupid or anything like that. In your real life, in your real education, in the real world outside of SAT preparation, algebra matters. It's important. It's a skill that you're going to use. But my job isn't to prepare you for any of that. My job is only to prepare you for the SAT and to put you in a position to get the highest score you can as efficiently as possible. With that in mind, there's not really any situation ever where I would recommend that anyone ever taking the SAT would use that kind of algebraic solution. If you're incredibly comfortable with math, if you regularly get 800s on this section and the whole thing is no big deal to you and you just want to kind of show off because you have extra time and you're going to do the algebra solution, go for it. Or if you're incredibly just comfortable with math, good at math in general, and something about this approach feels right to you and you can get it done in the time limit, fine. But it's certainly not the most efficient way. It's not even close to being the most efficient way. And as we'll see in a minute when we look at some other solutions to this question, there's other ways to answer this just so much more quickly. And the algebra approach just really doesn't make any sense when we remember that the College Board allows us to use the built-in DESMOS graphing calculator, which is going to be the much quicker, easier, much more straightforward path to the right answer. So with all of that in mind, let's go ahead and dive into one of these solutions. As always, when it comes to SAT math, we need to make sure that we understand the words and the concepts in the provided prompt. In this case, we have this idea which says which ordered pair is a solution to the system of equations above. We need to know that a solution to a system of equations is an ordered pair where if we plug the x value in and the y value in to all of the equations in the system, we find that this ordered pair is a solution to each of those equations. In other words, if we were going to take this x value from A and plug it in here, and then take this y value from A and plug it in here, and then we subtract that y value from that x value, the result would be 1. And then once again, if we took this x value again, plugged it in here, and then took this y value again and plugged it in there, we would also find that that x and y value would produce a true statement in this second equation as well. Again, that would be the case if A is correct. That's what a solution to a system of equations is. Another important thing that we need to understand about a solution to a system of equations on the SAT is that if we graph those equations, a solution to that system is going to be a point where the graphs of those equations intersect. And this concept is going to be pretty central to a lot of DESMOS-based solutions for a lot of real SAT practice questions, and it's where we're going to be able to really see the power of this calculator in saving us a bunch of time and energy in working something out algebraically when we can just enter it into the calculator and use the result to find the information that the prompt asks us for. With that in mind, let's go ahead and jump over to the DESMOS calculator and put in these two equations and see what we get. When we do that, the result looks like this. That first equation is x minus y equals 1, and the second equation is x plus y equals x squared minus 3. We just talked about how a solution to a system of equations is a point where the graphs of those two equations intersect. We can zoom in here and see that these two graphs intersect at 2 points. We have this one point down here and this one point up there. If we take a look back at the prompt, we see that it mentions the idea of a solution to the system of equations. So the idea that there's multiple solutions here seems to fit, and we're just being asked which ordered pair is one of those solutions. When we look back at that graph, we see that there's one solution up here in this quadrant with a positive x coordinate and a positive y coordinate, and there's one down here with a negative x coordinate and a negative y coordinate. Now we notice if we look at these answer choices that none of them has both a negative x coordinate and a negative y coordinate. There are a couple of negative values in here, but no answer choice has two negative values. So with that in mind, we know that we must be focusing on this point here with a positive x value and a positive y value. If we click on that point, DESMOS tells us that it is at 2.732, 1.732. For some people, that's going to be a little confusing because we don't see 2.732 or 1.732 in these answer choices, right? All we see is ones and negative ones and then radicals, right? Square root of 3 and square root of 5. But this doesn't mean that we're doing the question wrong or that we've made a mistake or anything. It just means that all of these answer choices has an equivalent decimal value. And if we figure out what that value is, then we can see which of these answer choices is equivalent to that point that we found on the graph. Basically every value in each answer choice includes some combination of a 1, a square root of 3, and a square root of 5. So if we can find a decimal approximation for the square root of 3 and for the square root of 5, we should be able to use the result to figure out which answer choice is equivalent to the point of intersection that we found when we graphed these two lines. So we'll go back in DESMOS, I will click this radical thing and then hit 3, and then it gives me the result right there, 1.732. That 1.732 definitely sounds familiar, right? That was the y value of this point, but just to be sure, we're going to find the value of the square root of 5 as well. That's going to be 2.236. Let's take another look at this ordered pair now that we know the values of those two radical expressions. Once more, that ordered pair is 2.732, 1.732. So that 1.732 is equivalent to the square root of 3, right? We can see that right here. That means that the y-coordinate of this point of intersection is 1.732, which is the same as saying that the y-coordinate is the square root of 3. Based on this alone, we can see that A must be the correct answer because only A has a y-coordinate that is the square root of 3. B has a y-coordinate of negative square root of 3 and an x-coordinate at square root of 3. But it doesn't have a y-coordinate that's just the positive square root of 3, and again, neither does any other answer choice here. To further confirm that A is correct, we can see that the x-coordinate is 1 more than the square root of 3. And that's the same as what we see here, right? 1 plus square root of 3. So that must be, if square root of 3 is 1.732, then 1 plus square root of 3 must be 2.732, which we see here in this point of intersection. So even though it took several minutes to kind of talk through each step and explain each step to you, if I actually saw this question on test day, finding the solution would take seconds. In fact, let's go ahead and do it in something close to real time so you can see how fast this would be. So let's say it's actually test day, I'm sitting down taking this test, I see this question, I read these two equations, I read the prompt that says which ordered pair is a solution to the system of equations above. I jump over to DESMOS, I type in x minus y equals 1 and x plus y equals x squared minus 3. I see this point of intersection here at 2.732, 1.732. I realize that the answer choices are presented as radicals and that this is a decimal equivalent, and I need to figure out which answer choice is equivalent to these numbers. I find the value of the square root of 3 and also the value of the square root of 5. And then when I see that only choice A has a y value that is the square root of 3, that is equal to positive 1.732, I know that only A can be correct. So even in that solution, I kind of stopped and explained it to you a little bit, but that's still, again, a matter of seconds just using the calculator, checking the answer choices, and finding the right answer. Again, using DESMOS, this is super, super quick, especially when we compare it to this approach the College Board wants you to use, which involves writing out a ton of algebra, which is also a ton of opportunities to miss a sign or make a mistake expanding an expression or whatever. Using that calculator allows us to avoid all of this and make this an extremely quick and easy process. I'll take a quick aside here to point out that this is, in my opinion, one of the shortcomings of Khan Academy as well. I feel that Khan Academy can definitely be helpful when it comes to learning some of the subject matter content that's going to be on the test. If you are unfamiliar with some of these math concepts, like the idea that, a solution to a system of equations is a point where the graphs of those equations intersect, that kind of thing. If you're rusty on any of that, Khan Academy is a great place to go and kind of brush up on that. But pretty much all of the math solutions in Khan Academy rely on, algebra, more formal math classroom type solutions. Khan Academy is not going to show you how to use the DESMOS calculator to find super fast shortcuts to these questions. And a lot of these questions have these super fast shortcuts. And it's really going to help you out if you take the time to figure out how to find those, which again, Khan Academy is not going to help you to do. Just as the College Board official explanations, official solutions for their own questions basically proceed as though there is no DESMOS calculator, and they tend to provide you with the most formal, most algebraic, least efficient way to answer every question. Anyway, let's get back on track. I just wanted to point that out because a lot of people on the internet talk about the benefits of Khan Academy, and there certainly are some. But almost nobody points out this particular shortcoming. If you're using Khan Academy to brush up on your math, and that can be a great option, make sure that you also know that you need to invest your time in getting really comfortable with DESMOS and making the most out of that resource to make those math solutions a lot quicker. I actually have a pretty comprehensive SAT math training video free on YouTube that is focused on the idea of making the most of the DESMOS calculator. I'll go ahead and link that at the end of this video. So I just showed you one way to take this 2.732, 1.732 ordered pair and figure out which answer choice that's equivalent to. If that didn't feel comfortable or intuitive to you, there's a couple other ways that we can approach this. One way is that we can actually just graph each of those ordered pairs and see which one lines up with one of the solutions to this system of equations. So I'll go ahead and type those out. So as we can see, we can go ahead and enter each coordinate pair into the graphing calculator just as they appear in the answer choices for this question. We can even label each one A, B, C, D, and we can check the graph and see where each one appears. We have A up here, right at that point of intersection. We have B down here, which is on this line, but is not a solution to the system of equations. D is also on one of these lines, but not a solution, and the same is true for C. Once again, we see that only A appears at a point of intersection for these two graphs, which means that A is a solution to the system of equations. Incidentally, if you're not already fully comfortable with things like graphing points and changing the color of those points and labeling and all that kind of stuff, you should definitely check out my DESMOS training video for the SAT math section, which again, I will link at the end of this video. So yet another way that we can figure out which one of these coordinate pairs with these radical expressions is equivalent to the decimal expressions we see in this ordered pair, which is a solution to the system of equations, is to use this calculator to just calculate out each of those x and y values that appears in those answer choices. For example, the x value in A is 1 plus the square root of 3, which is 2.732. So we can just write that out here. We have 2.732. And then as we saw before, the square root of 3 is 1.732. My excellent real-life handwriting is only made better by writing on this tablet thing. Knowing that 1.732 is the square root of 3, we can see that B is going to be 1.732 comma negative 1.732. Now to find C and D, we're going to need the value of the square root of 5. Again, we just use DESMOS to find that. Square root of 5 is 2.236. That means C is going to be one more than that, which is 3.236 comma 2.236. And finally, D is going to be 2.236 comma, and then negative 1 plus the square root of 5 is 1 less than the square root of 5, which must be 1.236. When we write out the decimal equivalent to all those answer choices in our terrible red handwriting, again, we can see that A is the choice that's equivalent to the ordered pair in this point of intersection. You may have noticed when we found the decimal equivalent of A, we could see already that that was 2.732 comma 1.732, just like we saw on the graph, but that we kept going to find the decimal equivalent of all of the other answer choices. This is an important concept that's discussed at length in my SAT Prep Black Book 3rd edition, which is that one of the best ways to make sure that you didn't make a mistake is to not just stop checking the answer choices when you think you found the right answer. A lot of times the small mistakes that people make in their solutions can be revealed when we remember to check every single answer choice. If you end up, for example, finding that more than one answer choice seems to be correct, you know that can't be the case, and you know that you must have made some kind of error. So I always advise my students to check every answer choice and not just stop when one looks like it's correct. Cool, so that is about that as far as solving this question. Now let's kind of take a step back and think about the things that we can learn about SAT math questions in general, and really about how the SAT works in general, when we think about some of the things that were going on in this question. Once more, I'll point out that the College Board solution is explained here. Going to involve a bunch of algebra, going to take a while, going to be a lot of opportunities to make mistakes. Not something I really recommend. I also want to point out the quote-unquote explanations for the wrong answers. For example, we have here, choice B is incorrect. Blah, blah, blah yields da-da-da-da-da, which isn't a true statement. Choice C is incorrect. Substituting blah, blah, blah yields da-da-da-da-da, which isn't a true statement. Choice D is incorrect, da-da-da-da-da, this isn't a true statement. Basically, each of these explanations just says, this choice is incorrect because it doesn't result in a true statement. This kind of explanation is only going to be helpful for someone who pretty much already understands this question and how it works. Most of these wrong answer choices would be the result of making an algebra mistake when employing this unnecessarily long and inefficient algebra solution. That's another advantage of using the graphing calculator, is we can't really fall for those kinds of wrong answer choices. Now let's get into what I think is one of the most interesting aspects of this particular question. If you asked me whether this was an easy, medium, or hard SAT math question, given what I know about how to solve questions like this, as we did in this video, I would certainly consider this to be an easy question. It has to do with solutions to systems of equations. This is a concept that comes up a lot on the SAT math question. It has this minor wrinkle that we talked about, which is this x squared term that we probably wouldn't typically see in a classroom situation with a question like this. But even so, when we use DESMOS to find that point of intersection and then figure out which answer choice expressed, with radicals is equivalent to the decimal expression of that solution that we saw on the graph, once we figured that out, finding the right answer is a fairly quick and straightforward process. Again, to me, this is absolutely an example of one of the easier, more straightforward SAT math questions. The College Board rates this with these 3 blue squares. That means it is a hard question from their perspective. And this, to me, gets into what I think is probably the major weakness of the current design of the test. And I don't mean weakness in the sense of something that a test taker can exploit. I mean, basically, in my opinion, something that the College Board really screwed up with this digital adaptive version of the SAT. Because difficulty is not objective. You can find objective measures of something and you can call that something difficulty, but that doesn't change the fact that the difficulty itself is going to be experienced in a different way from one person to the next. It also doesn't change the fact that we can miss questions, not because we're not capable of answering them correctly, but because we made some small mistake or we were in a rush or whatever. So when the College Board tries to get fancy and use their algorithm or use their whatever their secret sauce scoring process is that they kind of hint at but never come right out and explain, when they do that and when it depends on the idea that some of these questions are easy or medium or hard, inevitably they're going to assign a difficulty level to something, probably to a lot of some things. That's not really going to reflect the experience of some students, maybe of most students. When your adaptive scoring process depends on that difficulty level being accurate, and then when it can't be accurate, you're going to get the situation that you currently have, which is a lot of students getting confused about why missing 1 or 2 questions seems to have a disproportionately high impact on their score. Now, the thing about the way the College Board has decided to score the digital SAT is that we can't do anything about it. I think they messed up big time here, but the fact that I think that doesn't change anything. In my test preparation advice, I prefer to focus on the things that we can do something about. We can't change the way the College Board scores this test. But here's what we can do. I see a lot of test takers on the internet trying to analyze whether the second module in the test that they just took was the hard module or the easy module, and using that as a gauge of how well they did on the first half of the test, and going through this process of trying to evaluate these questions for difficulty as they're taking them, because they're trying to predict how well they're going to end up doing based on which module they got, and on and on and on. Your brain only has so much bandwidth, and your brain only has so much focus. And if part of your brain is trying to analyze this aspect of the questions that you're answering, while you're doing it, that alone is going to take brain power away from the task that actually matters here, which is just answering the question in front of you. I want to be really clear about this. Any time, any energy, any focus you allocate whatsoever to trying to figure out whether you have the hard module or the easy module or whatever else is going on with the test that you're taking right now, any amount of that happens is taking away from your ability to answer the question in front of you. That's actually the only task that you have on test day. Answer the question in front of you as efficiently as you can, and then move on to the next question and try to answer that one. If you hit a dead end, come back to it later. But no aspect of your score is determined by your ability to guess whether this module is the hard one or the easy one. Beyond that, being distracted by this idea is also going to produce anxiety in pretty much any test taker, because you're worried that you did badly, that you messed something up, and that now you're on the easier module and there's going to be a lower ceiling for your score, and now you're going to have to take it again and your parents are going to be mad at you, or whatever it's going to be. It turns into this sort of spiral which takes away from your only actual task, which is, again, just answering the question that's in front of you. This is further complicated when, as we just discussed, we can have questions like this, which to me are quite easy. And if I were trying to guess what difficulty level the College Board would assign to this question, I would certainly think, oh, this seems like one of the easier questions. Well, apparently they think it's a hard question. So you could be pretty good with DESMOS, pretty comfortable with it, and you could have questions that you think are the easy questions, and you think, oh no, I screwed up, I'm in the easier second module, and you could just be wrong about that. You don't know whether the College Board considers a question to be easy, medium, or hard. So even if you could determine that accurately, it's a waste of time anyway, because it doesn't affect your performance. But you can't determine it accurately anyway, because once more, it's not objective. Anyway, I could go on and on about this topic, and I could go on and on about the College Board's weird and, in my opinion, bad scoring process. That's not really the focus of this video. If you'd like to see a video on that topic or something like that, please feel free to leave a comment to that effect. For now, I want to wrap up this walkthrough video and kind of look ahead a bit and talk about picking the next walkthrough video. If you thought this walkthrough video was helpful and there's a real SAT practice question that you would like me to explain in the same way, then please head to this comment section below this video and feel free to comment the question ID of the question that you would like me to explain. Again, all of those questions come from the College Board's SAT question bank on their website. So you can follow that link, which is in the description for this video, to that question bank. Again, find the question ID of the question you would like me to explain, whether it's a math one like this or a reading and writing question. Leave that comment below, and the comment that has the most likes is the question that I will discuss in the next video. If you want to leave multiple question IDs in the comments, that's totally fine. Just leave a separate comment for each one. Again, it's always going to come down to which one has the most likes. So if you'd like me to answer your question, comment it below. Feel free to get your friends, family, whoever to like your comment if you want to try to boost it to the top. I had a busy week this week, so I think I'm going to go ahead and declare the winner not this Sunday at midnight, but the following Sunday at midnight. The comment that has the most likes at that point will be the one whose question I explain in a video just like this one. I might go ahead and leave a couple question IDs down there in the comments that I think would be good to discuss. If you see those and check them out in the question bank and you want to see a video about them, feel free to like those, or again, leave your own comment. Anyway, that wraps up this video. I hope that you liked it. I hope you found it to be helpful. If there's a question from the College Board's real SAT practice question bank that you would like me to discuss next, go ahead and find the unique ID number for that question and leave it in the comments below. Again, that's all for now, and I will see you in the next video.